Hi there, and thank you for taking the time to attend this session. My name is Chetan Kapoor, and I'm a Senior Manager with the EC2 Product Management team. In this session, we're going to review how we are innovating to provide you with the broadest and deepest portfolio of machine learning infrastructure that are designed to give you the performance, scale, and cost structure that you need to build, train, and deploy your machine learning models. Our ultimate goal here is to enable you to be highly effective in using machine learning to solve complex business challenges or to bring your innovative products to market. In this session, we'll review the capabilities of some of our latest generation EC2 instances, such as our P4D instance that provide the highest performance for training deep learning models, or our Inferentia-based instances that feature silicon that we've built from the ground up. We'll also provide guidelines on ideal use cases for each instances and how best to leverage them to scale your machine learning workloads into production. I've been with AWS coming up on 5 years now, and it's been fascinating to see the adoption of machine learning and deep learning over the years. ML has gone from being an aspirational technology to mainstream really quickly. For a long time, the technology was limited to a few major tech companies or hardcore academic researchers. But things began to change a few years ago as the overall adoption of cloud computing ramped up, and along with pervasive availability of compute platforms that were easily available in a pay-as-you-go model, researchers and developers were able to tap into these capabilities to really quickly ramp up on machine learning and start deploying models in production. ML now is making an impact across practically every industry, such as automotive, finance, retail, fashion, healthcare, and others. To enable our customers to accelerate the adoption of machine learning, we're investing across our entire machine learning stack. At the top of the stack, there are two services. There are services and solutions that are helping customers adopt ML without having the need to build a model from scratch. With the right data in place, these services can help customers be up and running with using AI-driven applications in minutes with practically no ML experience required. Our solutions address common business problems that are either single services or combination of services, and in some cases provide an end-to-end experience. Our ML services such as Textract or Amazon Rekognition or Poly, these are services that are designed to integrate in your existing applications and come with pre-trained models that are ready to act on the data that you provide and present and provide results and predictions right away. At the middle layer, we have Amazon SageMaker. SageMaker allows developers and data scientists to build, train, refine, and ultimately deploy their machine learning models at scale. It includes a broad set of capabilities, many of which are novel and unique to AWS. And it provides a fully integrated development environment for data scientists and machine learning engineers to build and deploy their machine learning models. At the bottom of the stack, you'll see our frameworks and our investments in the infrastructure. These investments essentially are designed for advanced machine learning users who want to, build their solutions directly on top of our infrastructure. And at this layer, we provide optimized frameworks such as TensorFlow and PyTorch, and also include computing platforms that include GPUs and our custom ML silicon. This is a portion of the stack where we're going to dive deep in this session and talk about some of the advancements that we have made in this space. Over the last few years, like I mentioned, the adoption of machine learning and deep learning has really skyrocketed. There are a couple of other trends that are also at play here. We're seeing that models are becoming increasingly complex, and customers are switching from using classical machine learning models to deep learning. Now, the reason why customers and researchers are doing this is because of their desire to develop models that provide higher accuracy and ultimately translate to better predictions and end user experiences that are more personalized and more appropriate on a per use case basis. Now, as these models are getting more complex, they're also becoming increasingly more challenging to train, and the cost that is associated with these training runs is also skyrocketing. It's an interesting trend where, initially, in the early days of deep learning, it was fairly common for models to take weeks to train. And there was a lot of innovation in the industry, both at the algorithm level and at the infrastructure and the hardware level, that cut down those weekly training runs down to daily and in some cases hourly training runs. Now, with this inflection point where in the last few years, the model complexity has really skyrocketed, we're back to a point now where it's taking weeks to actually train deep learning models of these particular sizes and magnitude, right? So our customers are, again, excited about what this technology has to offer, and they're telling us that they want AWS to innovate at the infrastructure level, at the framework level, and help bring the time it takes and cost it takes to train these models back down so that customers can innovate more frequently and have increased agility to go to market with their particular solutions or applications. Outside of that, data scientists and ML engineers also want to continue using the software tools and hardware platforms that are actually best fit for their use cases. Although, over the last 5 years, the adoption of deep learning has really picked up, we believe that it's still early days for this technology, and we need to provide the developers and machine learning engineers with the flexibility and choice to make sure they're able to pick the right tools for the right application. In order to address these challenges, like I mentioned earlier, and to lower the time it takes to train these deep learning models and the cost, we have been innovating across that spectrum. For training, our P family of instances are best fit for deep learning training applications, as they provide the most powerful GPUs coupled with high-performance CPUs, memory, networking, and it really enable customers to maximize the performance for training their deep learning models. As I mentioned earlier, not all use cases, not all model types are of the same type. We do see that for some small-scale training workloads or training less complex models, our G4 instances that we have in our portfolio are a really good fit. When it comes to inference, our Inf1 instances feature Inferentia, which is a homegrown silicon, and provide the lowest cost in the cloud for running deep learning inference applications. We also recommend our G4DN instances for inference workloads that prefer to use NVIDIA libraries and customizations. Let's dive deep into some of these instances. So starting off with P4D, we launched P4D instances late last year, and they are one of the most powerful computing platforms available in the cloud for training deep learning models. These are based on A100 GPUs from NVIDIA, and are able to lower your cost to train over prior generation GPUs by almost 60%. Besides the reduction in cost to train, there's a pretty significant increase in performance. we're seeing cases across a whole slew of benchmarks where P4D instance is able to offer 3x higher performance than our prior generation P3 instances. Now, besides rolling in the latest and greatest GPU from NVIDIA, we have also been innovating across the other portions of the instance platform. P4D instances are the first instances in the cloud to offer 400 gigabits of networking connectivity. They support a technology called EFA that allows for low latency communication across nodes. We'll dive a little bit deeper into that in the next few slides. They also come with higher GPU memory, tons of local storage, and up to 1.1 terabytes of in-system memory for storing your data sets and your complex models. By many accounts, this is the most complex platform we have ever built, and there's a lot of innovation packed in at the instance level. But we didn't want to just stop there. With P4D instances, we also introduced a concept called ultra clusters. Ultra clusters represent a deployment strategy where customers are able to consume thousands of GPUs, all interconnected via a fully non-blocking, high bandwidth, petabit scale networking infrastructure. This enables our customers to take on that challenge of building and training cutting-edge models on AWS and really optimizing their time to train. Besides having numerous amounts of P4D instances available that are all interconnected via high-performance networking, we have also added FSx clusters that are available as part of ultra clusters, and also enabled our EFA technology to work across the entire network. So the combination of EFA and FSx along with P4D give our customers a really ideal combination of compute, storage, and networking to train these state-of-the-art models in a short amount of time, and get their innovations to market as soon as possible. Diving a little bit deeper on the EFA side, over the last few years, we have seen more and more customers express interest in doing distributed training. Distributed training is where you take a large number of accelerators across several nodes or instances and have the training run across all these nodes to significantly cut down the time it takes to train these models. For these type of training runs, a high-speed network interconnect is crucial to enable effective low latency data transfer between all the nodes. Besides looking at the throughput that is available, latency of the communication or the time it takes for the first packet to arrive is also super important. This is where we have innovated to introduce a new network adapter called EFA. EFA is built on the AWS Nitro architecture that you can attach to certain EC2 instances. It allows for a kernel bypass, meaning the network card is able to directly transfer the data set from the network onto the application's memory, really optimizing the latency and also providing better stability on the network transactions. So EFA has been enabled across P4D instances and is the ideal network adapter to provide high throughput, low latency communications for these distributed training runs. We also innovated to integrate EFA with a technology called GPU Direct. Now, what GPU Direct does, it allows the capability where the packets that are arriving on the network card can be directly routed to the GPU for processing or for acceleration, right? So this further cuts down the latency and improves the stability of the network interconnect, yielding in higher performance. Over the last few months that P4D instances have been out in the market along with EFA, we've been receiving really positive feedback where customers are sharing data points where they're able to see the same level of efficiency and scale out performance as they saw on-prem using dedicated hardware, custom networking, as they're able to see on P4D instances. Based on the fact that P4D instances are available in the cloud, customers can be up and running in a matter of hours instead of waiting on days or months for data center build-outs and deployments of on-prem hardware. Again, a super exciting combination of capability across the compute and on the networking side. As a data point, we benchmarked the capabilities of P4D instance with our prior generation P3D instances. In this case, we use a model type called T5. That is a text-to-text transformer model for natural language processing. It's typically used for document summarization and for question answering type of applications. The T5 model increased the number of parameters by an order of magnitude over the commonly deployed BERT large model. For this particular comparison, we compared the time it took for us to train a T5 model across 2,000 V100 GPUs available in P3D instances and compared it against, again, 2,000 A100 GPUs that are available as part of our P4D instances. As you can tell, we were able to cut down the time to train T5 from a little over 12 days to under 6 days. So 2x improvement in time to train, which is a significant benefit. If you look at the efficiency of your development teams and being able to innovate quickly to try different permutation and combination of the models, tweak it for your use case, and eventually get it to a point where it provides the required accuracy and you can deploy it into production. Now, besides continuing to offer the latest and greatest GPU instances, we're also working on providing our customers with solutions based on silicon from other providers, and also silicon that AWS is building ourselves. In the coming few weeks, we'll be launching Habana Gaudi-based EC2 instances. These instances are expected to provide up to 40% better price performance over comparable GPU-based instances in our portfolio. For more information on Habana Gaudi-based instances, please click on that URL to learn more. As I mentioned earlier, we are also continuing to invest to build our own silicon for training of deep learning models. AWS Trainium-based instances are expected to be available in late 2021, and we expect that these instances will offer the lowest cost in the cloud for training deep learning models. Both of these platforms will support common machine learning frameworks like TensorFlow and PyTorch, and our intent with offering GPUs from NVIDIA, Habana Gaudi-based instances, and AWS Trainium-based instances is to provide our customers with the most comprehensive portfolio of instances for training deep learning models across the cloud, bar none. And as I mentioned earlier, we still believe it's early days for deep learning, and we want to make sure our customers have access to the right tools and the ability to optimize their time and cost to train their deep learning models on a per use case basis. Now, across our GPU families, we have our P3 instances that are based on NVIDIA V100 GPUs. We have our P3DN instances that feature, again, D100 GPUs, but higher amounts of GPU memory. They come with higher amounts of networking capabilities. And as I mentioned earlier, we have our P4D instances that provide the highest performance available in the cloud today. Now, different types of workloads and model types are going to have different fit with these particular instances. P4D instances and P3D instances are available only in the largest size, which provide access to 8 GPUs. On the other hand, our P3 instances provide access to smaller size instances that provide access to 1 or 4 GPUs also. So for applications where you're trying to train or fine-tune a particular model, or maybe train models that are less complex, models in the same category as ResNet 50, or if you're doing hyperparameter tuning, our P3 instances are still a great platform for those type of workloads and use cases. On the other hand, if you are doing, if you're training models such as MassQR CNN, or if you're fine-tuning or pre-training BERT-based, our P3DN instances are a great fit. For use cases where you're training a really large model like BERT-Large or GPT-3 or GPT-2, or perhaps a model like DLRM, our P4D instances are going to be the best fit. Generally speaking, they provide the highest performance and the lowest cost for training these complex models. These complex models, the primary reason why they're a good fit with P4D instances is because they scale well and they're able to saturate the full capability or the full performance that is available in a P4D instances and 8 A100 GPUs. For really large-scale distributed training runs, as I mentioned earlier, P4D instances come with 400 gigabits of networking, EFA. They're available as part of Ultra clusters where you can spin up thousands of these GPUs as a part of a single training run. P4D instances are a really good fit. So again, for distributed training, P4D instances, for training simpler, less complex models, our P3 and P3DN instances still provide great performance and cost to train. Now, across GPUs, Habana-based instances, and Trainium-based instances, like I mentioned earlier, we still believe customers want the additional flexibility to try out the right platforms for the right tool. So we would recommend using GPU-based instances for use cases that benefit from high-power GPUs. These GPU instances typically have the broadest support for frameworks and for deep learning models. And they also have a pretty strong ecosystem of developers and developer community around them. Habana-based instances are going to be new in the industry. They're going to provide great support for certain common frameworks and model types. And as I mentioned earlier, about 40% better price performance. The software ecosystem and capabilities is going to evolve quickly over time. Right out of the gate, we expect good performance for common models, and it's going to grow over the next following quarters and years as the software matures. AWS Trainium-based instances are going to be unique to AWS Cloud. They'll only be available via EC2 in AWS. And we expect them to provide the lowest cost to train deep learning models. At the instance level, we also expect them to provide the highest performance across our entire portfolio. Now, similar to Habana-based instances, Trainium-based instances will have support for common models and framework types, and the software ecosystem is going to out of the gate is going to work well for certain use cases, but it's going to evolve fairly quickly to expand the type of models that are trainable along with framework optimizations. Now, switching gears to inference and talking about infrastructure capabilities to accelerate machine learning inference, Again, we have a pretty broad portfolio. CPU-based instances such as our C5 instance or our M5 instance or our upcoming instances based on Intel Ice Lake processors are really, really good at running small models and for use cases where the throughput is not that high. If you're thinking about deploying complex models, specifically deep learning models, and if your use case is sensitive on throughput and latency, this is when we would recommend considering using GPU instances or some sort of a hardware acceleration. Now GPUs, or at least a GPU instance is based on NVIDIA GPUs, in many cases will require for you to utilize the NVIDIA software such as TensorRT or Triton in order to maximize the utilization of these GPUs and get the best price performance. Lastly, we have AWS Inferentia or our Inf1 instances that are excellent when it comes to providing high throughput and offer the lowest cost in our portfolio for running deep learning models in production. Let's dive deeper into some of these instances. Talking a little bit about Inferentia or Inf1 instance, our AWS Inferentia is the first silicon that AWS built for deployment in EC2. Is custom built for running deep learning inference workloads. These instances are wrapped up in an instance called Inf1, and our Inf1 instances offer up to 70% better or 70% lower cost to run these deep learning models in production. The software for Inferentia is integrated under machine learning frameworks such as TensorFlow, PyTorch, and MXNet. And what this really enables for our customers and users is that they can get up and started really quickly. They can continue using the framework of their choice, and with the Inferentia software plugged in under these frameworks, they're able to get started really quickly and get their models to be running on Inferentia with minimal code changes. This software architecture also gives them what we call as code portability. So in this case, since your application is not specifically consuming or tapping into libraries or software from AWS, if in the future there's a different application or there's a different hardware platform that better meets your application needs, you'll have the ability to really quickly and easily move over and take advantage of the future hardware acceleration packages at different instance type. Inf1 instances are available through standard EC2 instances, and are supported under deep learning AMIs, or you can also use them through EKS and SageMaker for a managed experience. As an example of getting started and being up and running with Inferentia, let's take a short code example. So in this particular snippet, we're showing you the minor modifications you need to make to your code in order to be up and running with Inferentia. In this case, there are literally 2 lines of code that we have to introduce in the standard transformer Hugging Face model to be up and running with Inferentia. The first line just imports the neuron library, and the second line actually invokes the compiler that consumes your model and converts into an intermediate representation that can be executed on the Inferentia chip. Once the compiler kicks in, the output artifact is a binary file that has been compiled to run effectively on Inferentia. Now you can take this compiled model and start deploying it across your fleet of Inf1 instances and be up and running in a matter of minutes. We've already seen great adoption of our Inferentia-based instances. A number of our customers have either deployed their deep learning inference models onto Inferentia-based instances or are in the process of doing so. These include customers like Autodesk, Snap, Anthem, and Condé Nast. Besides external customers, we're also seeing great adoption of Inferentia-based instances internally. Teams like Amazon Alexa, Amazon Ads, and Rekognition have migrated to using Inferentia-based instances over their prior generation platforms. Diving a bit deeper into Alexa's use case, Alexa uses deep learning models to generate or synthesize human-like speech in response to a user's input. Today, about 80% of Alexa's voice responses are synthesized on Inf1 instances, leading the team to about a 30% reduction in their costs. Now, besides reducing cost on a per synthesis or per inference basis, the Alexa team also saw about a 25% reduction in response latency. Now, this is pretty significant because this reduction in latency gives the team additional headroom to innovate, to bring either new types of voices or new capabilities in the same amount of latency budget that they previously had. Ultimately, gives them more headroom to provide a better customer experience. In order to get started with these instances quickly, we provided a range of options for our customers. We recommend customers to explore the use of Amazon SageMaker. As I mentioned earlier, SageMaker is a fully managed service that provides customers the ability to build, train, refine, and ultimately deploy their models quickly. And it's the quickest and easiest way for customers to get started with our hardware-accelerated instances for deep learning. For customers who want to manage their own platform and have a preference for deploying containerized-based workloads, all of these platforms and instances are supported under ECS and EKS. And finally, for customers who want to directly consume EC2 instances as virtual machines, they can also do that. And in order to help the customer experience there, we provide our deep learning Omnis and deep learning containers that come pre-configured with common machine learning frameworks and interfaces to enable you to get up and running quickly and right out the bat. So as a summary, from an ML infrastructure perspective, we talked about a few trends where customers are switching over from using classical machine learning models to deep learning models. The complexity of these deep learning models is going through the roof, and it's taking days and in many cases weeks to train these really complex deep learning models. So on the AWS side, we are laser focused on providing you with the deepest and the broadest portfolio of infrastructure offerings across compute, networking, and storage, available all through types of different managed experiences or unmanaged experiences, giving you the capability to pick the right components that work best for your use case. We also talked a bit about our P4D instances, which offer industry's highest performance for training complex deep learning models. They're available via Ultra clusters, where customers have the ability to spin up to 4,000 GPUs as part of a single training run. And we also talked about our Inferentia-based Inf1 instances, along with our G4DN instances that provide really great options for deploying or running deep learning models in production. Great. So with that, I would also like to recommend for you to check out aws.com/training. Our training and certification programs are really easy to consume and get started with, and give our customers an easy on-ramp to learning some of the core concepts around AWS, and also our instances such as our hardware-accelerated instances. Thank you for your time. Really appreciate your participation here. As a follow-on, please complete the session survey. Your feedback is super important. It helps us understand what type of content you actually prefer, and gives us an opportunity to continue to improve and deliver more compelling sessions for you. Thank you, and appreciate your time.